Hello and welcome to this lesson about prime numbers. The learning target of this video is writing a number as a product of its primes. So before I get into anything else here, I just want to explain exactly what it is we're going to be doing here. So product, that word means multiplication. So what we're going to be doing, the goal here, and it seems kind of weird, is just to write multiplication problems. Write multiplication problems. So if we keep that in mind, I think that's going to make everything a lot easier because there's a lot of fancy words and there's some vocabulary that's going on, but really we're writing multiplication problems. So first, let's now get into some of that vocabulary. All right, first of all, what are prime numbers? So prime numbers are numbers whose we're looking for factors, and it's the only factors are 1 and itself. So these numbers cannot be divided by anything, and that's what makes them special. And so in that regard, there's sort of like these building blocks that we can use to make other numbers. And so why does this matter? Well, exactly what I just said right here. They are the building blocks of our math system when we're using multiplication. And so sometimes it's really helpful to kind of see how a number is made, to see how a number can be multiplied by other things to get to it, because that can do a lot for us. And so that's ultimately why we're doing this. It kind of helps us understand the building blocks of numbers, and it lets us do some fancier things because we can now get the structure of how numbers work. So let's talk about, let me do that really quickly. All right, very good. Prime factorization. So again, we got a fancy word here, prime factorization. This is a multiplication problem. Multiplication problem with prime building blocks. That's not how you spell building. So that's what we're going to be doing here. It's just prime factorization is where we take a number and we make it into a multiplication problem, but all the pieces that are being multiplied together, all these blocks, are these prime numbers. Numbers whose only factors are the number and or the number itself and 1. So for example, let's start off really simple and small. Let's say we take something like 6. Well, the prime factorization of 6 is 3 times 2. Because you can't break down 3 and 2 to anything else. That's as far as it can be broken down to. If we were to think of 6 as being 6 times 1, we could break down that 6 as 3 and 2. And so that's where we haven't written the prime factorization. So this right here, actually this right here, is our prime factorization, which I'll abbreviate as PF, prime factorization. So now let's kick it up a notch and do a couple of examples. So, examples, how to do this. So let's say we have a number like 18. So what I like to do is make the factor tree where you kind of break it down, because then you can kind of start anywhere and you'll arrive at the right answer if you break things down properly. So like I know 18 is 6 times 3. 3 is a prime number. I can't break it down any further, so I like to circle all my prime numbers. However, 6 is even, so I can break that down as 2 times 3. And so I will circle those. And then to write something as its prime factorization, which is what we're trying to do here, I like to write them in numerical order. So 2 times 3 times 3. Now remember, that little dot there, this little dot, is a multiplication dot. If you wanted to, you could do it with the multiplication x's, but eventually we start bringing in variables, so if we can use a dot, it makes life a little easier so we don't confuse ourselves. And that's it. This is the prime factorization for 18. Now let's try a different number. Let's make these numbers slightly larger. So let's look at something like 40. And actually what I'm going to do is I'm going to write 40 over here as well, and we're going to do it two different ways. So again, I like the factor tree method because I can break it down however I want. I could go, hey, this is 8 times 5. And look at that. I've already found a prime number. 5 is a prime number. I don't need to go any further. But I need to keep working on 8. Well, 8 is 4 times 2. And then 4 itself can be broken down to 2 and 2. And so here, I like to, again, circle them all. And now I can bring them all together. We have 1, 2, 3 2's, and the 1 5. Now, let's break down 40 a different way. Let's say, hey, it's ending with a 0. That means this is 10 times 4. Well, here I'll have 5 and 2, and here I have 2 and 2. So that's the thing with prime factorization, is we're just trying to get down to all of the basic components. Several ways you can do it. On the left here, we went 8 times 5, and we had a couple layers deep. So we had 1, 2, 3 layers. Here, we only have 1, 2 layers, and that's totally fine. It doesn't change anything because those prime factors are still the same. We have 1, 2, 3 2's, and the 5. All right, and then finally, let's use a much, much larger number for lots of fun. Clean that up. There you go. All right, let's now do the number 156. Ooh, okay. I don't know all the factors of 156 off the top of my head. So here we have a couple of options. I see that it's an even number. I'll break it down by 2. And it's easy to cut things in half. So like, what's half of 15? Well, it's 7, and then that'll leave me with 1 over there. Okay, 78. Now I can keep breaking down 78. Well, 78, you know, that's still even. So I'll take out a 2, and then let me see here. When I take 7 and I cut it in half, I'll get 3. But there'll be a 1 left over. Okay, and then that will be 9. All right, now you might be thinking, okay, what's 39 a multiple of? How can I break down 39? Well, this is where we have to use our divisibility rules. 3 plus 9 is 12, and 12 is a multiple of 3, 12, so that means that the whole thing is a multiple of 3. So I can put a 3 there, and then this is 13. And now I've taken it as far as it can go. 2, 2, 3, 13. So its prime factorization is 2 times 2 times 3 times 13. All right, and there it is. So that's how we do prime factorization. Like I said, all we're doing really is you're writing multiplication problems. So writing multiplication problems, where each one of these pieces that we're multiplying is a prime number. So good luck with your homework or practice, and let me know if you have any questions.